Now we want to model the structural component of this vertical vessel, and first we go through vertical support legs, which is oriented as the manner shown in the general drawing, and there are 4 legs as shown in this drawing. And the dimensional properties is given in the elevation and orientation views of the vessel. The legs are welded to the shell one, so we choose the leg dialog and click on leg icon. And the node that we have to give the distance from is node 20. For the selection of the distance from the node, we have this dimension over here, 350. And the leg orientation, I'll tell you later what is this. And the number of leg is 4. And we have to calculate the overall length of the leg in accordance to the general drawing we have over here. Take a look at the connection of the leg to the shell one, and we decide to put the correct number for the overall length of the legs. It's likely to be 2,500 plus 35 straight flanging, and the number given in the DWG details of the weld connection of the legs. $2,500 plus 35 plus 350 minus 45. This is the overweight I have selected for the legs, and the effective length is the free length of the leg. For the formula in AISC, it has to be a free length. $2,500 plus 35. The profile is a German profile, IPB 200. We will find it, and here The properties of the profile is given by PV Elite. IPB200. There is a effective end condition Ka. If we take a look at the PV Elite manual, we will see that the common value for pressure vessel is 1 or 1.5, and because we are taking both ends as pinned connection, we don't modify it and leave it to be 1. And the leg start angle, we have to see the general drawing. This starts at 45 degrees, but let's take a look at the PV Elite manual, what this value is. It's a value between 0 degree and the starting leg. It's 45 in this case. Occasional load factor, we will not modify anything, and because we have pad in the leg connection, we are going to fill these boxes for the pad. The pad width 245 and the length 550, and the thickness is 10. And if we click on compute center line diameter, it automatically computes the center line diameter of the leg. And we are not going to check any of these boxes. And the legs are modeled except for the base plate. We need to model the base plate over here. Check the base plate and put the initial guess of the dimension of the base plate. It has 45 millimeter thickness, which is a thick base plate for this vessel. And I'm going to find out any related material to base plate which doesn't explicitly given in the DWG or datasheet of this vessel, and I'm going to take it as SA36. Of course, it has to be taken as the plate, and I mistakenly taken it as bar. And for the bolt, something is given in the datasheet. SA193 B8 is the material for anchor bolt. and thermometric is taken as the thread series. And in accordance to the DWG, there are only 2 anchor bolts for this vessel. Run the model. And the initial dimension for the base plate is not correctly selected. We have to modify it. 300. Click OK. Run again. It needs further modification. It seems that the 300 is not big enough for this vertical vessel. 350. Click OK and run the analysis again. The same error. $500 for the third choice, and click run the analysis to see what happened. And it seems that the 500 is a correct answer, but before it we had to put the seismic data into the seismic data information of the PV Elite list, and we have to put these information correctly in PV Elite. In the general drawing, it says that the code for evaluating earthquake is ASCE 7 2010, and the seismic code is ASCE 7 2010. I'll select it. And put the coefficient in accordance to the DWG. The importance factor is 1.25. R equal to 3, FA equal to 1, FV 1.3, SS 1.163, and S1 is 0.6. These coefficients shall be given by the civil engineering department. And the wind standard is ASCE 7 2010, which is already selected. And the exposure is C, and important factor is 1. And only the Wind speed is 195. Run the analysis again to see if there is anything wrong with the dimensional of the base plate or legs, and we try to optimize the base plate a little more. It doesn't need any modification, and select a thinner plate for the base plate. $350. We'll try again. We are going to optimize the base plate, and the anchor bolt is given in the datasheet. Everything is selected and chosen correctly. Now 350 doesn't require modification. 370. We'll try it. Click run the analysis, and everything is fine. Now we will model the lifting lug for this vertical vessel. Select shell 2 and try to put the right information for the lifting lug. For the elevation and the layout angle, we go through the general drawing and see the lifting lugs. Two lifting lugs are at 135 and 315 degrees. So we choose 135 for the start angle, and for the distance from node, we have to see the PV Elite manual to see what it means for lifting lug. For a vertical vessel, the centroid of the weld group, for example, the base of the lug plus 1/2 the weld distance on the side of the lug. If the vessel is horizontal, enter the distance from the left end or tangent of the vessel to the center of each of the two lugs. Now we'll see the weld group of this lifting lug. Go through the drawing. There is a drawing for this lifting lug. I've taken a photo from it, and it helps me to calculate the center of the weld group. "30 plus 100 is the pad of the lifting lug. And the distance from this node 30, shall be calculated in accordance to this image. "680 is from the node up to circumferential welding line. So 680 minus 100 minus 50 plus 35 plus 50 might be the right value for this. Some of the fields are not smart and they cannot calculate the subtraction or any operation. We will fill the dimensional for the lifting lug in accordance to the DWG. This value is from the OD surface of the vessel to center of the hole. 15/2 plus 10. And the dimension of the fillet weld is usually taken as 0.7 times the bigger thickness of the joint. Of the thinner thickness of the joint. I'm calculating the dimensional in accordance to the DWG and put them in the right boxes of the lifting lug. There is no color. We take it as 0, and the lug material is as the shell material. And because we have pad, we have to put the dimensions for the pad. The lug is slotted at the bottom in accordance to the DWG, and we put the dimension of the slot over here. And click OK. Click Run the analysis. There is a warning of lifting lug is higher than top of the vessel.